The most exciting, most sought after, most rewarding technologies worldwide are those that give back. Green technologies. Pro1 Extreme Lubricants, addressing virtually every sector, manufacturing to transportation, mining to space travel, trucking to agriculture. Pro1 lubricants save time, money, and energy. It's technology of the future, benefiting you and the world now.
Thank you. Now I'd like to take this opportunity to introduce to you an exciting lubrication technology. It has been tested and proven around the world in our commercial and industrial and automotive application, and it's environmentally friendly. The technology is used throughout our whole product line. As you know, is all of the lubricants that you're familiar with, they float on top of water. So we're going to take this technology and we're going to add it to water. And what you're going to see, it does go all the way to the bottom. That is not the importance. The importance is that this is a positively charged molecule structure. This is negative and this is positive. And when you put a negative and a positive together, this is extreme pressure lubricants, XPL plus. And that's what the plus stands for, is a positively charged molecule structure. Not alone does this do this for metal surfaces, but also for all your seals and gaskets and transmissions that have nylon guides and so on in them. I'm going to use this plastic pen, and you can see the ability at the molecular structure for this product, and hopefully the camera can catch this, and you can see that it's going to cling to all the parts. You can't stop this technology from working like this. Now, not let alone does it do this, we have another step of water displacement that I'm going to show you. This is called a cross-axis friction machine. I'm going to explain this to you in just a minute. But as I turn this on, what powers it, of course, is electricity. I'm going to pull this apart, and what holds this connection together is metal. Brass, copper, tin, and the same technology that you just saw there as a positively charged molecule structure. Now bear in mind, this is a bonding lubricant working with flowing lubricants. So we're going to take this and spray this connection, and you're going to see that it bonds to it. Now this is the highest dielectric strength available, and I'll explain to you why. As you can see, I've got the spades exposed, and I'm going to just take this beaker of water. Now I don't recommend that you do this at home, but I can take and I can put this under water, and I can put my finger in here. There's no bleed off whatsoever. You're seeing a technology that you've never ever seen before. I can take this apart, and I can still take this hot cord and put my fingers in it. Fingers, electricity, and water are not compatible. Now I want to tell you at this particular point that the same thing that you saw right here is working with cutting fluids, with hydraulic systems that have water problems. Water displacement in lubrication is a problem. As you know, it sets up oxidation and corrosion, and we protect from that. That is part of the plus technology. Now when we change this technology, part of the ability for the product to cling to the metal is because of this change of polarization. Now to help explain that, this is called a cross-axis friction machine. Now what makes this machine very, very viable out there for testing, it is an ASTM approved testing method for testing the shear strength and the overall extreme pressure film strength of lubrication. Now, the components that's working here, you've got this spinning race, comes in a box like so, and then you've got this C62 Rockwell hardness race, and that's what's on the end of the shaft. And then it comes in a box like this, and then the other component that we have is this C58 Rockwell hardness tapered roller bearing, and this is what's in my bearing holder. Now we put these two together on this cross-axis friction machine, and this is how it works. When I put 6 pounds of pressure here, if you want to look at the gauge here, it comes out about 125 inch-pounds. And that, at that point, through this geometrical progression of leverage, gives me 4,000 pounds per square inch here. When I pull this needle all the way down to the other end, I now have, at point-to-point contact, all the way down here at the race in the bearing, I have 200,000 pounds per square inch. No, there is nothing out there on the face of the planet that requires that kind of lubrication. So let me get into a good everyday lubrication. This is on the automotive side, but bear in mind this technology is working through all kinds of industrial, commercial applications. We're using a top-of-the-line synthetic motor oil that performs well over 400 degrees. This is a good product. There's nothing wrong with it whatsoever. But when you get under extreme pressure lubrication, that internal combustion engine and transmissions and gears and all different components that lubrication is under, this gives you an idea of what the lubrication goes through. I'm going to put just a fingerful of pressure, and you see that it broke through that barrier and a minimal amount of pressure. And you watch the amp gauge, goes all the way over to the other end, and I'm going to run this for 7 seconds. In 7 seconds, you're going to see that this high temperature performing synthetic is going to reach its maximum performance, and you'll see the smoke come off the bearing. Focus on the smoke that comes off the bearing here. I'm going to run it for 7 seconds. 1001, 1002, 3, 4, 5, 6, and 7. And you can see all this smoke that's coming off the bearing. Now in that very short amount of time, look at the excessive wear mark that we ended up here. I'll turn it just a little bit so you can see that. And then how rough it is in the center. And yes, that is excessive. So what we're going to do is we're just going to rotate this bearing around and have this mark on the side. So we have the rough spot that's over here. So we have a smooth spot here available. I'm going to take and I'm going to remove this product right here. And what you folks will be carrying with is an everyday petroleum-based product. Let me show you, and this will happen every single time, is you see all these metal parts? That kind of wear did not need to happen, and that's what's left behind. And that, if these wear particles get between a crankshaft and a main, you've got excessive wear that's happening. I'm going to clean this bearing up just real quick here and go to, so there's nothing left behind. And this product here is a good petroleum-based product. This is your inexpensive lubrication that is available out there in most of the vehicles. We have a smooth spot on the bearing here. And again, just takes a fingerful of pressure. Now this product has well over 300 degrees, about 325 degrees. I'm going to run it 7 seconds. Take note, as you see smoke coming off the bearing, it'll be inside that 7 seconds again with a fingerful of pressure. 1001, 1002, 1003, 4, 5, 6, and 7. You can see all that smoke and so on coming off the bearing. Very, very similar as what you could see to the synthetic product, which is a real good product also, but this represents about 98% of the lubrication that's available out there on the market. Now the other two, let's say 95%, because you do have a percentage of people that say if they don't like this lubrication, then what they do is they go to other additives. And this is the majority. That's why I wanted to do it at this point here. I'm going to take another product, and what's understood out there in the industry, set this off to one side for just a second, and I want to turn this thing on. Now this is pretty acceptable out there on the market, that the thicker and the heavier that you get in viscosity gives you better protection. Oftentimes they'll use, you might go to an automotive store and you'll see little wheels on the counter, and it'll take real thick, heavy lubrication to take it to the top of the wheel on one side and not so far on the other. And what I'm going to do is move this bearing over to another smooth spot. Our last wear spot is right here. There we go. And I have another smooth spot, and we'll take a look, and you can't even see you can't even see the wheel now. It's so thick and heavy, and I'll give it the same 7 seconds, but watch how quickly that the smoke comes off, because thermal protection, the thicker that you get oil, the harder it is to protect. Now watch what happens to the smoke coming off the bearing now. 1001, 1002, 1003, 4, 5, 6, and 7. I know you've seen this product work on counters, and it just takes just a fingerful of pressure, and the more that you touch it, I mean, the little more heat, and it just goes upside down. Now, in this very, very short amount of time, you can now see the exposure of the race and that real thick and heavy. I barely got it to 100 degrees. I can hold my finger in there. And that real thick and heavy, gooey, syrupy, it's gone. And the hotter that it gets, your temperature is going to run in excess of 200 degrees. Your thermostat will keep your engine running well over 200 degrees. So this is technology that you see on a counter working at 75 degrees. And let's take a quick look on what actually happened to it. You can see again that you have an excessive wear spot, and you see how rough it is. Now, I want you to focus on that one. It looks almost identical to this one right here, if the camera can pick that thing up. It's all pretty jagged and rough. I'm going to leave that thing there, and now what I'm going to do, I'm going to clean this thing out just for a second, and then we're going to go and add our technology to this. And there are all kinds of products that are available out there on the market. And one of them I'd like to show you, one that you've probably seen. It taunts a Teflon technology. And it's made by DuPont. And actually it's branded as what they call PTFEs, Teflon. And that refers to is polytetrafluoroethylene, closed pore resin plastics made by DuPont. And I'm going to clean this thing off so you don't have any questions whatsoever that a residue from another product was left behind. But what I want to show you, if you see all this white stuff at the bottom, that's your PTFEs. And I'm going to turn this thing upside down. You see that running back and forth? Now, if this gets caught up in your oil galleries in your engine, you've got some serious problems. Again, in this technology, there is no magnesium, zinc, graphites, Teflons, PTFEs. And while I'm here at the moment, while I'm explaining that, this technology that you've seen is wrapped up. This is a finished product, one of our several finished products. This is our engine life treatment. I like to put it in a clear beaker because, as you can see, there is no solids, no magnesium, zinc, graphites, Teflons, PTFEs, no solids. The biggest thing is it does not void any warranties whatsoever. This is a beautiful product in its performance and its color, and so we haven't lost track here. I'm going to put the base product, real good product. There's nothing wrong with this product. I'm back, and I'll hold this thing here to our last worn spot there, okay? And I'll put that on there. And just so you remember where this product stops, right here with a fingerful of pressure. Now, what we're asking you to do, in this case here, in an engine oil treatment, and this also works in diesel and in gasoline, it works in petroleum and in synthetics. This product here is going to be added at 10% to the volume. I want you to listen to the noise. Now I'm going to add just a little bit of this technology. And this would be like pointed into your crankcase. Now listen to the noise difference. We got the squealing and so on, so we add just a little bit of product. And here's the secret to this technology. This is a polarized product, and the hotter that you get it, the better it works. It's sucked right into friction. This is a bonding lubricant working with flowing lubricants. And just as you could see, poured a little bit out of that beaker. We try to get 10%, and we can sit there and pull on this thing, and you've got incredible performance of Extreme Pressure Lubricants Plus. This is Pro1. And in this very short amount of time, I'm going to give it here just a few seconds, and this would take probably 1,000 miles on gasoline and probably 2,000 or 3,000 miles on a diesel, because the components inside that diesel are a little bit harder. But as if you can focus on this, you have worn parts in your vehicle. You may have 20,000, 30,000 miles. You could have a couple of 100,000 miles on your gas, or maybe 600,000 or 700,000 on your diesel. We take worn parts in there and create harder, smoother, and now you can see that this is polished. Now, what we're going to do, and then you can see the roughness of this one over here, and you can see, yep, it's across the light, how that's all polished now. And the longer that you use it, the better it works. Now, this will also help extend your oil change. Let me give you an example on the diesels. I'm going to refer to a 18-wheeler going down the road. Most of those rigs have 44 quarts or 11 gallons. You're going to put in 10%, which is 1 gallon. And when I talk about extending the oil change, let's take an average around 16,000 miles on an over-the-road rig. With this technology, you can extend it, that 16,000 minimum, up to 20 to 22,000. And how we do this is through TBN, total base number oil analysis. Very, very important. Now, what we've done since our last, we polished up a very worn spot. And what we're going to do now is we have a brand new spot, and we have our technology mixed with a good base lubricant. And this is about 10%, and all of the lubrication so far has stopped right here. But you notice that the amp gauge went way over to the other end, okay? Now I'm going to put a little more pressure, and then a little more pressure, and then a lot more pressure, and I'm at the very end of the numbers at 200,000 pounds per square inch, and you can see that the amp gauge, we're barely at 8 amps. Okay, with all that excessive pressure, the performance, you would expect a deep gouge in here, and this is what we're very, very happy to present to you, is Extreme Pressure Lubricant Plus by Pro1 Lubricants, Extreme Pressure Lubricants. This is your performance. That little tiny dot that you see is 50 times 4,000 pounds in regular lubricants and 200,000 pounds with 10% of this added to it. What I'm going to do now is pull this thing all the way down, and you can see what it does. But now what I'm going to end up doing is taking, and you know that if you get a blown head gasket, that when water gets in, somewhere between 5 and 6% to the volume of a little bit of water, it wipes out all of the mains. So I'm going to put just a little bit of water in here, and then I'm going to put a little bit more, and you know that water floats oil. Okay, so I'm pouring all kinds of water in here. I'm now running at 100% water. Just the film, that protection, the same protection that you're seeing right here, the same, you cannot stop this lubrication from doing this. The same protection you saw here is now happening here. And yes, this is excessive. And we'll sit there and pull this thing down and pull it and pull it and pull it. And this is running at 100%. This is a horrible environment. But wait, it gets worse yet. Let me tell you what happens to your engine. You have an air cleaner up on top, and that air cleaner is letting some dirt in. You talk to any of your mechanics and so on with an engine that has a lot of miles, whether it's an everyday gasoline engine, and it gets, let's say it gets 250,000 miles on it. That's a lot of miles for a gasoline, or it gets 800,000-900,000 miles for a big diesel rig going down the road. This is just dirt from the flower bed out in front. And yes, you do get this through your air cleaner. A percentage of it still gets by, and it creates an excessive amount of wear. Now,